Hey everyone, this week we are going to be going over some more Statcast stuff. This time it will be getting and obtaining temperature data and manipulating with that. So what we're going to do is from the unique game packs or game IDs of each game in the 2019 regular season, we're going to pull from those game packs venue name, so what park was the game played at, temperature, other weather, so if it was overcast, cloudy, rainy, windy, so on and so forth, wind, and then start time. So that way we can kind of explore more data ideas in that sense. So first, load baseball R, load tidyverse by calling the library. I already have that ready to go, and then we're gonna call Savant. So I'm just going to say read Savant hitting data 19 to have all data of hitters, and then strings as factor is false. Maybe this CSV file may not be the same for you. You may have named it something else, but as long as it's baseball Savant related data, this is how you load it in. And then what we'll do next is we'll get those unique game packs. So since I already have it loaded, I don't have to run that command, but make sure you do, and it'll appear in your environment for Savant. So what I'll do is now we'll say game packs equals unique Savant game pack. So we know what kind of game packs that we have, and we can be able to manipulate that and go through some interesting data stuff there. So what we'll do next then is I always like to create a sample data set. So that way for future use you can see kind of what it looks like in that sense. So I'll say sample, get 10 samples from the data set. Now what we're going to do is essentially create a loop. But first, I want to show you with Baseball R, you can get game info. So we'll look at this. So 565, 997. So we'll say game packs. We'll say what? 565,992. In Baseball R, there's this function called Get Game Info MLB, and it'll show you essentially what kind of stuff that you can pull with that game info. So we pulled the first one, so it's 565,992. We're going to run this command, Get Game Info MLB, and it'll give you game date, game pack, venue name, venue ID, temperature, other weather, wind, attendance, start time, and it's got more. So I'll actually put this in a data frame so we can see this. So I'll say, I'll just say temp. So we'll put this in temp, and then we can view it by doing this. So it gives you game date, game pack, venue name, venue ID, temperature, other weather, wind, attendance, start time, elapsed time, so how long was the game ID, game type, so this was a regular season game, home sport code, so MLB, official scorer, the name of the official scorer, date, again, and then status IND, home league ID, and then game day underscore SW. So feel free to play around with that, and we can kind of do some other stuff. But what we'll pull is what I mentioned earlier. We're going to pull game pack, venue name, temperature, other weather, wind, and start time from that data set. So how you do that is, again, we'll create a list. So I'll say weather equals list, and then again for I in 1 to length, since we want to have the length of game packs. We'll do weather, I, indicate what element in the list we want, and then baseball R, or you can just say get game info MLB, since you already have baseball R loaded into your library. So get game info MLB game apex I, and then we'll do select game pack, venue, name, temperature, other, weather, wind, start time. So we have that kind of data. And I'm not going to run this because this does take a lot of time to run. It is getting that game info for, based on this data set, 2,427. It might be more for you, might be less. But it is pulling each of those game IDs for you, in which case then it's getting that information. Now, after your loop runs through all the way, again, some of you might need to add something like a SystemSleep. So how would you achieve that? Simply down here we'll say sys.sleep, and then we can say 0.01. Because again, it might, depending on your computer performance, it might be a little bit slower than your computer can handle, or I say a little bit large in terms of capturing memory that your computer can handle. So if you feel like your computer won't be fast enough to handle all those requests, add a SystemSleep like I just mentioned there. And then once your list is added, how do we put that into a singular data frame? Very common. We'll say wdata plier ::, indicate what function we want in the plier package, ldply, then weather, data frame. So I'm not going to run this since, like I said, I already have it, but run this and then you'll be able to have that into your data set. And then to merge it with Savant's data set, we'll say merge. So we'll say Savant is our data set, merge Savant, which is our X, wdata is our Y, which is our weather data, and then by game underscore pack in quotes, indicate what column. And then, of course, we want every Statcast data, so all X equals true. Once you have successfully merged the Savant dataset, you can write a new CSV or overwrite your old CSV. So you can say write CSV Savant, and I'll say Savant with weather.csv. So, and then make sure you say row names equals false because you don't want row names. But either or, you could do a new CSV file or overwrite your previous CSV file. Either way, it'll work. But let's go into now seeing what kind of data is present in that Savant dataset. So again, we'll run Savant sample in 10. And we'll go into our sample. And it gives us 10 random samples. We're going through, go all the way to the end here. And now we have stuff like venue name, temperature, other weather, wind, start time, temperature time, or not temperature time, temperature type. But that actually is in my Savant dataset. So I'll actually show you how to add that into your dataset. So we're going to say Savant equals Savant piping operator, and we'll say mutate temp type. So we have that temperature type, and it's just going to be a bunch of if-else statements. So if else temperature is less than or equal to 40, we will say very cold, less than or equal to 40. And then another if else temperature is greater than or equal to 41 and temperature is less than or equal to 50, then we can say cold 41 to 50. So we're basically creating 10 grouping types. I'm not going to write out the rest, but just make sure you have enough parentheses. So actually what I'll do is copy and paste the code that I do have written for it. so you know exactly how many parentheses you might need. So here we go. So just make sure you have enough parentheses. It should, so that one, and then for the mutate call. So you should have 1, 2, 3, 4, 5, 6, 7, 8 parentheses here at the end, and it just completely lists through. So cold, very cold, cold, moderate, 51 to 60 degrees, mild, warm, 61 to 70 degrees, warm, 71 to 80 degrees, mild heat, 81 to 90 degrees, and then hot, greater than 90 degrees, otherwise NA, which you shouldn't get any NAs in your data set because it's all within those confines. So now that we have that, we can actually check if there is NA in your temp type variable. So we'll say savant som.is.na savant temp type, and see there's no NAs, so we do have all of those ready to go. Now what we'll do is kind of create various tables or plots, and one is, off the top of my head, is grouping by each temperature interval, not by tens, but like each singular game temperature, and then plotting those results. So how we do that is simply, we'll call temp as a new data frame, savant, piping operator, group by, and then this is important here, we want to convert temperature to a factor. So that way we have those different levels of temperature. So we have a level of 33 degrees, 34 degrees, 37 degrees, you know, and it keeps on going forward. And you'll kind of see visually here shortly. But then we'll do summarize through the dplyr package. So I'm just going to do this just so I know I am using dplyr summarize. And we'll call a variable called mean exit velocity, which is mean, or the average of exit velocity. And then we want to remove any NA, so na.rm equals true. And then continuing on, we want to have results in each section. So results equals n, and then that's parentheses, both sides, to indicate how many different results in each temperature grouping is there, or how many batted balls in play. So we're going to run this. We have that in our data set. What we'll do is adjust the temperature name to match the rest of the column. So it looks like that we do have a random name. So how we change that, since it's just for one column, we'll do col names temp, and then since it's the first column, we'll do in square brackets 1, then we'll say temperature in lowercase. So now we should be able to have that. All right, great. Now we can plot it. So let's make a simple plot. So we'll say ggplot. Temp is our data set, and mapping our aesthetics. So x equals temperature, y equals mean, EV, and then we'll say we only want one grouping, so group equals 1, and then size equals results. So it's adjusted by size. Now we'll call a geom line and a geom point. So we'll say geom line. I'll add a color. I want to do contrasting colors, so I'll say color equals red for the line, and then I'll say geom point, and then we'll say color equals blue. And we'll be able to run this, and we can see, not necessarily right away, but I'll be able to zoom in here shortly, but we can see most of the games appear to be in that 70-degree range. Now that I have the plot zoomed in, we can see that most of the games were right around that 70-degree area, as you can display by the thickness of the point and the thickness of the line. You can see over here the various lines. So it looks like the mean exit velocity hovers around 83 for most games, but somewhere between 83 and 84. What I find interesting, even though it's a small sample size, 46 degrees has the second highest average exit velocity, and then 94 degrees has the highest, which, I mean, you should be able to expect that in some degree. Balls seem to travel further when they're hit harder in warmer weather. So I think this is a great idea, and it opens up avenues for so many ideas. Adding this kind of temperature data, I'll go back into the sample data set. It gives us more opportunities to explore more ideas, not just exit velocity. We could see, exit velocity launch angle combinations based on weather. Another idea could be to do called strikes in weather using Jim Albert's called strike package. You could do a called strike plot with that. You can definitely see if there's any differences in kind of pitch speed, either batted ball speed, stuff like that, between day games and night games. You can do more with temperature types, wind types, see if the ball is hit harder and more wind, especially if it's going out. Or you can see the average exit velocity when the wind's blowing out and seeing if there's anything there, but this gives you more opportunities to make more research, and I am recommending some to you. So I hope that at least one of you can explore more with this data. I was able to pull it for you. So yeah, feel free to tag me at RobertFry40 on Twitter when you do explore some of this data. That would be greatly appreciated. I would be more than happy to showcase it. But thanks for watching. Really hope you enjoyed this video. And until next time, we're going to continue on with either Statcast, college baseball, really haven't decided yet. But if you do follow me on Patreon, if you're a $5 a month subscriber, and I'll leave my Patreon description in the link. But if you are a Patreon subscriber, you'll see some of my future content ideas already in there. So feel free, if you want to donate and help me make better content and even greater content in the future. Feel free to chip in. Really appreciate it. But thanks for watching, and hope you have a great rest of your week.